everybody and welcome to this video. In this video, we're having a look at the geometric sequence again. So we're looking for the general formula which allows us to find any term in the geometric sequence. So the general formula for a geometric sequence is Tn is equal to AR to the power of n minus 1. Now, what you would notice is that there are two unknowns in this general formula that we would need to find. First, we've got the A, which is represented by the first term, and then we've got R, which is the common ratio, which we calculate by saying this, a term divided by the previous term. This concept we have went over in the previous video, so please watch our previous video on the common ratio. So a geometric sequence is a sequence that has a common ratio, which means that we are multiplying by the same number to get the next term in the sequence. So let us have a look at finding the formula using the general formula for these examples. So let's do it step by step. So we're going to start with the first one. Let me just put a line there. So number 1. So in the formula, we're going to have to first find what is A and D, because those are the two unknown, A and R, sorry, because those are the two unknowns. So let us look at the first sequence. The first term of the first sequence, 3, 1, and a third is 3. So our A is 3. And then we would like to get our ratio. Our ratio we get by dividing any term divided by the previous term. So T2 divided by T1 is 1 over 3. So our common ratio is a third. And that is the power of n minus 1. If you'd like, you could use your exponent laws to simplify it further. So this is 3 times 3 to the power of 1 minus n by taking the 3 to the numerator and changing the sign. And then finally, this here then simplifies to 3 to the power of 2 minus n once we use our exponent laws. So these two we simplify using exponent laws. Oops. Okay, so please go over your exponent laws so that you know how to solve those. Okay, so let's have a look at the second one. So once again, we have the general formula being equal to T is equal to AR to the power of n minus 1. And again, we're going to have to fill in what's n and A and R. So A is the first term, and the first term for this sequence is 4 over 5. R is the common ratio, so we calculate it by saying any terms. I'm going to say T3 divided by T2, so it's 20 divided by 4, which is 5. So our common ratio is then 5, and that is the power of n minus 1. We could simplify this further because of that 5 and that 5, so we can say that this is 4 times 5 to the power of n minus 2. That's moving using our exponent laws to include that 5 in the denominator over there. Okay, so let us have a look at the next one. So we have Tn is equal to, once again, A times R to the power of n minus 1. In the place of A, we put our first term. What is our first term for the sequence? It is 0, 1. Then the ratio, we get it by calculating dividing. So here I'm going to say T2 divided by T1, and then what I get is 0.1. So it's 0.1 to the power of n minus 1. And then if we then just simplify this using exponent laws, once again, we get 0.1 to the power of n. Okay, let's move on to the next one, number 4. So number 4, we have, again, it's a geometric sequence, so we're going to use the general formula for a geometric sequence, which is Tn is equal to A times R to the power of n minus 1. And in the place of A is our first term, which is 2, and then R is our common ratio. So here I'm going to say T2 divided by T1, which we then get 10. So our ratio is 10, and that's the power of n minus 1. So this particular one, I'm not going to simplify it further using exponent laws. I'll just leave it as 2 times 10 to the power of n minus 1. Now, number 5, people always get intimidated when they find letters in a sequence. The way we approach it is exactly the same. So it's a geometric sequence. We start with the geometric general formula, which is a to the power of r n minus 1. Then we've got Tn. We're going to put in the first term a. What is a? It's our first term, so it's Kp. And then R is our common ratio, so we can calculate it as T2 divided by T1, so Kp squared over Kp. And then if we divide that, we get P. So our common ratio is P, and that is the power of n minus 1. Again, using our exponent laws, we have that the P times the P to the power of n minus 1 is just P to the power of n. And there we have it, the general formula of that term. Please make sure that you've understood all of these examples, and if you have, please watch our other videos in the geometric series so that you can understand the geometric sequence perfectly. Thank you for watching, and bye.